Go ahead.
Okay, great. Hey everyone, welcome back and welcome to the new people. This is session 2 of the Azure DevOps Mini Bootcamp. We're going to be doing around 6 to 8 sessions of these bi-weekly, and in between each week we'll be doing a homework and Q&A follow-up. This is session 2, and I created a new project and I made it the project public. So if you were continuing from session 1, you'll notice that the project is now called Mini Bootcamp instead of DevOps Session 1. It's public, there's no login required, and the link is right there at the bottom of the page. It's also in the slides, they'll be posted up. It's on the reference page as well. So you can log in there and take a look at it. So anything that you see in session 1 that says DevOps-session 1 has just been replaced with Mini Bootcamp. It's essentially the same thing, and you can log in and follow along when you're doing the homework to compare your results with what we've done in each session. Today we're going to be talking about build pipelines and continuous integration. Last week we talked about source control and some best practices around Git and Azure repos. First, a couple of corrections. This might be a common theme at the beginning of each session. We're all learning as we go all the time, so please feel free to let me know if I'm incorrect on anything. Last session I was probably mixing and matching the terms continuous delivery and continuous deployment. So to clarify what that means, I kind of use them interchangeably, but that probably makes me a bad person. So the actual definitions are: continuous delivery is the frequent delivering of software that's deemed potentially capable of being deployed, but is not actually deployed. On the other hand, continuous deployment includes the actual deployment of that software. When I try to reconcile what that means to me, I like to think of it like you're always delivering your code in a state that's ready to be deployed. When I usually hear that, though, I think, well, what's the point? If it's ready to be deployed, then just deploy it. But as my parents used to tell me all the time, it's not all about me. And apparently they might have been right, because everyone else may not be ready. So people can be working on multiple features and they could be pending, and my changes may not be something that the team wants to go live until other features are ready. When everyone is ready, then it actually gets deployed. Then it's considered continuous deployment. Anyway, so in Azure DevOps, you'll see continuous deployment all over the place and not continuous delivery. We'll talk about that in the next session, though, but if you hear me mix those up a couple times, I'm usually referring to continuous deployment. So our next session, I left the incorrect slide up where it says delivery. We'll be talking about continuous deployment. So here's where we are in our objectives. This isn't going to go completely in order. The schedule, however, on the other page is. We are on step number 4 now, where we're going to be continuous integration with pipelines and artifacts. Number 3, bugs and boards. We'll probably do it maybe around the 4th session, and then we'll just keep going on. So we'll be on a fun little journey. So continuous integration and pipelines. Continuous integration is the process of merging. By the way, we only have 8 minutes maybe of slides, and then it's all demos. So continuous integration, it's the process of automated merging of developer work from source control. We're going to compile it, test it, and create an artifact for automated release. If you were ever involved in promoting code for developers back in the day, you may see why this is valuable. A developer used to create a package, they would verify it worked in their lab environment, then they'd deliver it to an operations team, then it would be scheduled and someone would go and deploy that software. If it didn't work, that process starts over again, and then it's very time consuming, even if it's as simple as, say, a developer handing the ops person a zip file for them to extract somewhere. Change controls and human processes make this very slow, so the pipeline is intended to introduce confidence through that automation and code review approvals, the continuous integration component. But now that we're down to pipelines, the fundamental purpose of a pipeline is to create an automated process that results in a repeatable and a reliable delivery of that software from the concept all the way to the customer. The goal of it is to enable a constant flow of changes through various environments. The pipeline starts by building the binaries to create the deliverables that end up getting passed on to a release process. And new features end up being implemented along the way by developers, and they're integrated into source code on a continuous basis. They're build tested. This is the cycle that informs the development team about the health of their code, and it gives them some confidence when their code is ready to be released. This is why branching is important, which is why we covered it first. You're not going to be able to make successful commits to your code 100% of the time. You're going to make mistakes, and you're going to be testing new things. As you work through those changes, you may need to commit dozens of attempts just to get something right. If you're committing to master branch every time and someone else started working from master, they may be introducing unfinished work into their activities, which could lead to unnecessary troubleshooting. So we know what CI and pipelines are, but what's the output? Builds. We're going to be talking about builds and artifacts. A build is the process of creating an artifact. Imagine that zip file that we were talking about from the developer to be extracted on a web server. That is a build. That is a build artifact. A build agent, which we'll also be talking about in a few minutes, these are the VMs or containers that the build process is executed on. It could be creating a zip file, it could be checking dependencies, it could be creating a Java jar file, it could be anything that results in an output that can be released. It can be in the labs and sessions, we'll be mainly working with the zip file of our web app, but it can be a lot of different things. Building, in our case, we'll be running .NET Build, which takes our web app that we created in the previous session, verifying all dependencies, creating that zip file of the contents that we'll later use as our deployment package. The build agents on the VM, there are two types of them in Azure DevOps. There's Microsoft provided agents and there are self-hosted agents. Brief explanation of the difference between the two. We'll start with the Microsoft provided build agents. These are agents, they're VMs that you don't have to manage. They're created at the time that you execute the build, and then they're deleted when the build process finishes, whether it was successful or not. They can be Linux, Windows, or Mac OS. You can still add software to that agent, like if you needed something custom to run as part of your build process, you can add that at the time of creation through these tasks that we'll cover in a second. And their basic capabilities without anything added are PowerShell and Bash. You can even use the PowerShell on the Linux build agents. There are time limitations on what you can do with an MS provided build agent. For a public project like ours, we can run 10 build jobs in parallel, and each job can run up to 6 hours each. There's no monthly time limit. If you look in your billing section of your DevOps subscription, you'll actually see a time, but it's something like 50,000 hours a month, which comes out to 30-something days. Private projects, on the other hand, they have a time limit of 30 hours per month and 60 minutes per job. However, you can buy parallel jobs to increase this to be more like the public projects. If you don't want your project to be public, of course, and you just need it private, you can increase the performance of your builds by buying more agents. They all run, be it public or private, on Azure DS2 v2 virtual machines. With the MS agent, you can't log into those VMs and you can't like RDP or SSH or anything and like play around with it. You do have access to execute things on it, but you can't connect directly to it. So if none of those things seem ideal for your situation, that's what the self-hosted agents are for. You can create a VM of your own size. You can install the VSTS DevOps agent on there, that's the build agent, and you can install whatever software you wish and it can stay there. You have unlimited time. You can scale this to however big you want it to be. And they don't need to only exist at the time of build. It can be a permanently running VM that increases the performance of the build process since it doesn't require initialization of some resources. And lastly, we mentioned artifacts, so we should talk about what those are. The output of your build is an artifact. That zip file is an artifact. In our case, we'll be creating a build artifact which is kind of a confusing name, I think, given that you can output other types of artifacts from the build process. So calling it a build artifact seems confusing. For example, there's Azure artifacts. Those are the output of a build process and are considered artifacts. From this point, though, when I say our build artifact, I'm referring to the feature of the pipeline called build artifacts and not the concept of creating an artifact. The reason why I'm saying this, which sounds very verbose, is because in a later session, we'll be talking about outputting Azure artifacts as part of our build process, where I'll hopefully remember to use the right term, Azure artifacts, instead of build artifacts. So blah, blah, blah. That was a lot of confusing stuff. Basically, an artifact is an immutable package that is the result of a successful build project. Just like your source control, you can version your artifacts, you can track them, and you can revert back to different build artifacts at any time. This is important because if you happen to deploy something that doesn't work as expected, you can revert back to the previous build that was made from your source. Without this, you'd have to revert back, you'd have to revert your code, build again, and then release. So both of those things are totally possible though. But reverting code could be problematic, since imagine you deployed something and you didn't realize there was an issue with it until later on. Your development team could be well on the cycle of creating new features, and reverting code would be kind of problematic. Whereas now that you have a version build artifact, you can just say redeploy with this zip file that we know worked on this day, and people can continue working in source and it doesn't affect them at all. So we're going to do 3 demos. We're going to take our Azure, not Azure web app, our .NET web app, and we're going to create an ARM template for it for an app service plan in Azure, and then we're going to add that to the repo. We're going to create a classic build pipeline and a YAML build pipeline. YAML is the new way of doing things, but you're definitely going to run into some classic pipelines, so we might as well cover it. Really quick though, I want to show you where I set the project as public in case you're interested. When you log into your DevOps instance, right on the home page, there's this organization settings. If you go to policies, and you have to say allow public projects on. And then inside your project, we're using the mini bootcamp one now. Under project settings in the bottom left, there's this visibility option here, and you set it to public. This means people can log into it or access it without logging into it. Cool, so let's get started. I'm going to clone this repo, going into the mini bootcamp project. Going to clone the repo. Here's all the stuff we had before. There's our web app, our gitignore file that we created. Even all the commits are still there, where we changed a banner twice. There's no branches right now. So let's do this. Let's clone this, and we're going to add our ARM templates for the app service plan, because that's where our web app is going to be deployed to. Just save this here and open it. We're going to create a new branch. Let's check out our files. Yep, everything looks good. So let's make a new branch, just like we did last time. We'll call it feature templates. And we'll make it from master. Awesome. Down in the bottom left, there we are. We're on our new branch. Just going to do something really quick here. We'll make a new folder. Call it templates. And I have some files over here. I'll go over what these are in a second. I'm going to drag them in. There we go. So we have our Azure deploy JSON. what these are is just the app service plan, the server farms resource, and a site. That's pretty much the generic hello world from when you spin one up in Azure on the portal. I went to the quick samples GitHub page and I just downloaded those. The only changes I made, in case you're following along exactly, are I changed it to F1 SKU instead of S1. So F1 is free. Then I changed the kind from app to Linux just because it seemed like a fun thing to do. It didn't really matter if it was running on Windows. The app we're creating will work on both. And I changed that down here as well. The last thing I changed was the web app name. In the quick start template, it had -web app appended to the back of it. So I just took that off because it just didn't look cool, I guess. And then we have our deployment parameters file. I provided the name of the web app here. So this gets used somewhere right there. That's all it was. So we've added our templates. Familiar with this already. We have 2 changes. I'm going to commit those changes because they look okay. We're going to publish the branch because we created it and it doesn't exist yet in the repo, the remote repo. Cool. And then we're going to sync it. All right, let's jump back over. Refresh the page. There's our new branch, and repo's detected that we made a new change and it wants to ask if we want to create a pull request. Exact same process as before. Takes the last code commit. I'm going to create this. And if you were on the homework call, you may already be aware of this, but now you'll notice that it says there's one required approver. We set up a branching policy where one person needs to approve. And since it's just me right now, I added myself as the approver. So we'll approve this. And we met the criteria just to make sure we know what we're approving. Looks like we added 2 files. Sounds great. We'll complete, delete the branch. And let's check out our work. Sweet, we see the templates folder. There's no extra branches. There's our cool little files. Amazing. If you're wondering where, just in case you missed the homework, the branching policy to set automatic approvers, you go under branches, branching policies, and right here, I set minimum number of approvers 1. I can approve myself and I added myself down at the bottom as automatic approver. Awesome. So we're all ready. We got the app, we got the templates. Now we're ready to start that continuous integration process. We're going to create 2 build pipelines. We're going to create one with Classic first and then the YAML one. So if you haven't created any before, this is the exact screen you'll see. We'll click on New Pipeline. And the difference between the new one and the YAML, or sorry, the new one and the Classic, Classic is right down here at the bottom. We'll start with this one. It's going to ask us where the source of our build will be. We're going to choose the repository that we were just putting those templates in, and we're going to use the master branch. It doesn't have to be master, it's just asking what's the default branch you want to create that zip file, say. All right, just so we know exactly what we're doing, we're not going to use a template here. We're going to start with an empty job, just so we know what it's like from the beginning. Okay, let's name this. We'll call it DevOps Mini Bootcamp Classic. And we're going to specify what those build agents are running on. And just because we're using Linux for fun, we might as well use it here as well. Let's say those VMs, we want it to run the latest version of Ubuntu. Awesome, 1804. I think, no, okay, that's good. All right, so agent pool. This is where if you had multiple agents, build agents, you can have them into a pool and you can specify it for a specific agent job, but it's inheriting it from up here. agent job, this is just a container where you're going to be putting all the tasks that qualify as your build process. We're going to be creating 3 build processes. 1, we're going to make an artifact of our templates. 2, we're going to run .NET build, or .NET publish actually, which is going to validate our web app. And then we're going to run a 3rd task, which is going to take the output of that .NET publish, a zip file, and we're going to publish that as an artifact as well. So let's get started on the first one, which should probably be the .NET publish. So if you click on the plus sign here, .NET will fill it in for you. There we go. We got a .NET core task. So there's .NET build. Awesome. I don't really want that. I want publish. Remember last time we were running .NET run. There's .NET build. All of these are just the exact same thing that we were running in the terminal. I'm going to choose .NET publish because publish does what build does, but it does one extra step of creating a zip file for us and placing it somewhere. So we're going to publish it. We're going to publish web project. That's going to put a folder in. It's going to name a folder after the web project when on the agent at the time of creating it. It's a default. It's fine. We're just going to leave that. I'll show you how to figure out what that does in a few minutes. Then arguments. I'm putting these just because I like to know where the output of that zip file is going to be. So I'm going to say going into build.artifacts staging directory. If you're wondering what this is a default variable. This is where all the staging happens for the build process. So when the VM build agent starts up, it's just an empty folder. What we're telling it is to run .NET publish and output a zip file, which is why this is checked, into this folder. It has like some crazy path like D:1/A/S or something like that, but it's easier to just remember this. And in the reference notes at the last slide, there's a link to all the variables that you can use. And then, oh wait, I'm sorry, the publish web project is, it's telling the builder to look for the location where the project is. The add project name to publish path is where it's making a folder named my web app. Let's see what other options we have. The working directory. This is kind of neat. When you click on the ellipsis, it's going to give you a list of all the files in the repo. We're focusing on this one, my web app. So let's go there. So it's telling us to focus on this directory. Cool. All right, so we'll hopefully, when this runs, have a zip file in a folder called my web app, and the file will be called mywebapp.zip. But that's not enough because we still don't have an artifact. What would happen is we would run it, the VM builder would execute, it would create the zip file in the folder, and then the VM would be destroyed and it would just say success. But we wouldn't have a file that we could do anything with. The reason for that is because we need to publish our file as an artifact to Azure DevOps. So let's add one more agent job. We'll call it build publish. Or publish build artifacts. Okay, so inside here, let's just give it a better name. We'll call it publish artifact my web app. This is going to be the zip file. The path to publish is that staging directory. Remember back here, I said I wanted it to go here, and so I would know where the zip file is. This is why. So I can then say, look in this folder, anything in here, publish it as an artifact. And I want to name it my web app. I'm going to be publishing it to Azure Pipelines. You do have the option of publishing it to a file share in case it's going to be picked up by some other automated process. Remember that if you are using the MS hosted build agents, I don't know if you'll even be able to publish it to a file share. Maybe if it's like a storage account that has open access, but you probably would be using that if you wanted to publish to a file share on-prem or something like that, and you were using your self-hosted agents. But we're just going to leave it as the default for now. And this looks pretty good. Before we add the third one, let's just make sure this works. We'll save it and we'll queue the build. And just like our commits in source control, we can add a comment to our changes to the pipeline. It's kind of okay, but I'll show you why this has a little bit of a shortcoming when we compare it to the YAML one. So let's say .NET and publish. This is funny. I get this every single time. So if you see this screen, I'm feeling it with you. Every time I submit a pipeline job to run for the first time using the classic editor, I can't click on the buttons, but it did send it to start running, so I just refreshed the page. Cool. So now let's go back to our builds. There's our build pipeline that we created. There's my last commit, and we have a little process animation here saying that it's running. And here's the steps that are being executed from our build process. Checkout. It's connecting to the repository. It's downloading all the code to the build agent VM. This only takes a few seconds. And then it's executing the .NET publish command, which the output should be a zip file. But we got an error. No such file or directory. Probably a typo. Let's go back and check out what's happening. Whoops. So we'll edit the pipeline. .NET publish. Output build. Oh, that's what it was. It should be artifact staging directory. I thought I could get away without having to copy and paste everything, but here we go. Let's try it again. So the desired outcome of this is we're going to see at the top when this process finishes is a button that says artifacts. And when we click on it, we'll be presented with a zip file. Let's find out. Here's that actual command, the .NET publish. And this is the folder I was talking about. Instead of the variable, it's /home vsts/ whatever. I would forget that every time. Let's see if I have the variables link while we're waiting. Nope. Never mind. Okay, so .NET publish is cool. We should have made that zip file. Then the publish artifact task. Took this file. There's that folder path with the app name in it, that checkbox we had. All right, so it's published a artifact for a pipeline. This component detection is there automatically. To be honest, I'm not exactly 100% sure of everything that it's doing, but this is the validation of, that everything is okay according to a .NET build. And then there's some cleanup before the VM's deleted. And now in the top right, we have this artifacts button with the My Web App. And when we click in there, hey, there's our zip file. Sweet. Let's go back and add that third task of creating an artifact of our ARM templates so we can use that to deploy our app service to Azure. So we'll just add one more. Except this one is kind of interesting because all of the time when we're talking about continuous integration and building, we're saying we're compiling our code, but ARM templates aren't real code that needs to be compiled. They're just a bunch of text files. So we can skip the entire process of compiling, which is what the .NET publish command was, And we can just take that folder full of the template files and publish it as an artifact, exactly like we did before. We'll publish a build artifact. Let's name this one templates. I don't think it matters if it's uppercase or lowercase, but just for the sake of it, let's do it. And path to publish. Again, here we see that arguably still easily forgettable variable name compared to the path on the VM build agent, but now we can click on these and drill down and select our templates folder. So now we're just targeting this artifact to publish what's inside of here. Cool, that's pretty easy. Let's save it and queue it. Adding templates artifact. All right, so we'll let that go because we'll let it go in the background. That's boring. We've already seen it before. It's just going to have one extra step on there. So let's talk about a couple of things related to continuous integration. With the classic pipeline for building, the way to enable continuous integration is you edit the pipeline, and it's not on by default, and you can select triggers, and then it's just this happy little button there where you just say enable continuous integration. And anytime that there is a change on whatever branch you select, it will kick off a build process. So we'll say, let's say you only wanted to execute a build process whenever someone committed a change on a feature branch. You can say exclude master, and then no matter what the name of the branch is that someone creates, it will trigger a build process. Or you can include master, so it only builds when someone creates a pull request. All those change commit notes that I was typing in there, similar to your version history when you're looking at your repository, you can see what the changes were to the pipeline. But this has a slight limitation, which is why the new YAML build pipeline exists, I think, among other reasons, I'm sure. So I see what I did here, like I added this and this and this, but you double click on it, nothing really shows up. You have to click on somewhere. Where was it? Oh, usually you would see. Oh, there it is. Okay. Oh, that was the first one. So then when you want to see what was actually changed, here's like some JSON output of who knows where it's coming from. It's like built into your DevOps instance. You don't actually see the files here. It's just giving you tracking of what was changed. So you don't really get to see, like there's no one approving it. Sure, you can restrict permissions of people who can change the pipeline, but there's no code review that you can do with all of your other stuff. So that's where the YAML stuff comes in, and I'll show you that in a second. Our new artifact release should be done. Hey, look at that. Cool, and there's that new task here, publish artifact templates. Same deal, put it into a folder. And now when we click on artifacts, we have two. We have our zip file, and we should have this. Whoops. Hey, there's our two files. So when we're ready to release this project, those are the files we'll be using to deploy it to Azure. All right, so let's do the same thing. I'm going to turn off continuous integration just because having multiple jobs running at the same time, we don't want to have everyone waiting for one to finish since we're doing a demo. I guess I didn't save it. Awesome. All right, so let's make a new YAML-based build pipeline. Instead of clicking on Classic Editor, we'll just answer this little wizard. Azure repos, that's where our source is stored. We're going to use this project. And a kind of neat thing that happens here is it knew that it was a .NET Core application. The reason why it does that is I think it's either because it looks for a .csproj file in the folders, or it looks for a www root and web.config. So it kind of tries to help you out. So we'll we'll go with it. And here's our new YAML-based pipeline. It was kind of helpful. It picked the latest Ubuntu. It automatically turned on continuous integration. That's what trigger means, just like we had in the trigger section on the old classic pipeline. Created a variable called release. This is just a parameter that gets passed to the .NET build command. And I mean, it's kind of okay. Let's see if it works. I'm pretty sure it doesn't work right out of the box, but just in case you run into this at the same time. I probably will get an error here. Yeah. Let's do this. Actually, no, this is going to make a bunch of extra clicking, so bear with me. I'm just going to change something really quick. I'm going to take off that branch policy that we were talking about just so we can get this going. And then we'll turn it back on once we're ready to start improving our code. Here we go. Awesome. Okay, so since we had that trigger option in there already by default, and we're creating a file that is now managed that is now our pipeline in a managed state, we should have a build process kick off automatically. So while this happens, I'm 99% sure it's going to fail. Let's look at the repo. This is why I took off that policy, just so we would always go right to the master and we would see what's going on. Using the new YAML-based one, it put this file into my repository automatically, and here it is. The bonus with this is now your pipeline is not that obscured, hidden JSON output that we were looking at in the classic one. It's an actual file, and the file means you can put that through your code review process. So if someone were to want to change the pipeline, they can do it through code and it has approval, whereas the other way, it was just like the person who has access can change it and they can kind of do whatever they want without someone approving it. So this is pretty powerful. Let's see if the build process succeeded. It didn't. And the reason why is because it can't find, so specify a project or solution file. So while it was clever enough, I guess, to decide and understand that the repo was a .NET project, it still couldn't find the project or solution file. But that's okay. I just wanted to show that just in case you ran into that. We're actually going to go back and fix this to the way we want it. We're going to make it look like all three steps in the previous classic pipeline. All right, so let's edit this again. And so this just brought up the YAML file. And let's compare what it looks like on the other one. I feel that usually helps with understanding exactly what we're doing, because this one is a little bit less gooey, I guess. Let's see if we can squeeze these into the same screen. All right, that kind of works okay. Let's shrink it a bit. Yeah, there we go. So we got the trigger, that's our continuous integration. We got the Ubuntu, so we're on pipeline here, Ubuntu. Sure, it doesn't say latest, but 1804 is the latest, and I guess this variable will mean that when 19 whatever comes out, that'll be the one that it runs. The build configuration, this was just it trying to help us out, knowing that it's a .NET build. Another option, if you're curious, would be debug, but we'll just leave it. We'll roll with it. This is the command that doesn't work, because it's a script trying to run that command .NET build, and for whatever reason it can't find the csproj file. I probably could have just put like /my web app and it would have worked, but we want to use tasks. These are the tasks. There's a couple ways to enter them into YAML file. You can do it by just typing task, and it tries to help you out a bit. And it will help you fill in what you're looking for. We know it's .NET Core, CLI, version 2. See task version 2 on the left side. All right, that's cool. And then we have some inputs. The command we want to run for this task is, like on the left side, publish. And arguments, we want, I'll just copy this because I typed it wrong last time. What else do we want? Oh, the project name. And the zip file. So zip, there we go. It's helpful. True. And the last one is the publish the path. So that would be, I'm just typing to see if it helps me. It's not. Oh well. I think it's something like publish web projects. Yep. That looks like it matches up. Is the working directory? Yeah. Nice. Oh, actually, you know what? Since it provided this configuration part, we'll keep that in just in case it's actually necessary. But it's probably fine. So that as our argument. So now it's going to run .NET as a task, publish command, put the zip file into the output directory that we specified. Awesome. And so that's kind of okay. I mean, it's cool to be able to type all that stuff and remember it or whatever, but you can also, when you're editing in this pipeline editing window, not when you're in the repo, it presents you with the settings, and it kind of looks similar to what we had on the left side. So you can kind of fill in the values there. All right, so we got the first one. Now let's add the second one, publish artifact, but we'll do it using the wizard here. So publish somewhere, publish build artifacts. Great. There's a few less options, but we know what we want. We're going to be using the same staging directory. We're going to change our drop or our artifact name to my web app, and we'll add it. Cool. And then we got one more, which was very similar to this one. So this one should be pretty fast. Publish build. Cool. Except in this one, we wanted just the templates directory. And you notice here the path to publish on the left side, we could just select and browse to it. On this one, we have to type it out. And we're going to name this templates. Cool. All right, so that would be the equivalent of what we see on the left side. So left side classic, right side new YAML-based pipeline. I'm going to save this, but actually, you know what? This is kind of fun. Let's see what happens if I jump over to the classic one. There is a little tool that will help you convert these to YAML. There it is. Sorry, my screen's not big enough. So when you click on each task, there's a view YAML, and it'll kind of help you out. So if you have a bunch of classic ones and you want to convert them over, it'll give you a little bit of a helping hand. Yeah, and see, this one didn't include the configuration, so it wasn't really needed. We probably looks like we got a couple extra things. Yeah, this is a perfect example. Zip after publish is not here, but it is checked here. So it's a good starting point. And if you wanted if you had a lot of stuff and you didn't want to click through each one, and you can click on the agent job itself, and it will give you all of the stuff. So it looks like we got everything pretty much set to go. Yep, awesome. So let's save this, and we'll commit it. And let's check our commits. And see, now that I edited the pipeline, it's actually an entry here in the commit history for the repo. Check out the build process. Should look very similar. There's our publish build, our .NET publish, and there's the 2 artifacts that we're going to be sending out. Okay, this will take another minute or 2. Let's see, we might have enough time to actually deploy this. Next session, we are going to go over continuous deployment, where we will do a lot of different things around deploying the app, but it would be kind of satisfying to actually do something with these artifacts. So let me just check my notes if we have anything while this runs. Yeah. All right, let's give it a shot. If this finishes in the next 30 minutes, or 30 seconds, we have 10. Oh no. Publishing build artifacts failed with an error. Path to publish. Let's check out our YAML file again and see what we missed. Path to publish. Templates, that's right. Oh no, that's not right. See, let's see what this would have told me. It wouldn't have told me either. I'm using the wrong directory. I was saying get the template files from the artifact staging directory, but they're not there. That's related to us staging the web app. Let's change it to where it actually clones the repo, which is called build dot no, system.default, that's it. System.default working directory /templates. Maybe needed that as well. Yeah, let's give it a shot. So one cool thing about this is while you can't log in directly to the virtual machines that are running the build agents and do whatever it is you want on it, if you did need extra software installed on it, that's what these tasks are for. If you need to install Node.js or an extra PowerShell module, you can do this right here. And if you don't know, if like there isn't something specifically identified in here that you need, you can create your own. And if it's something that's just executable on the command line, like through PowerShell invoke web request or whatever, you can add it here by adding a PowerShell task. But you can also just execute commands by typing -script and whatever you want. So this is what I kind of do if I'm troubleshooting. These directories and these variables to directories, I kind of forget them a lot. So sometimes I might just say, what like directory is the agent? What's the default working directory or the present working directory for the agent? I can type pwd and we'll output that as a step. I can say script. So say I was trying to find out what's in this system default working directory. I can say dir that, and if I save it, the next time it runs, oh cool, it looks like our previous one was successful.
Hey, Mike, this is Lance speaking, just to wake up the audience for a little bit. What you can do, right, you can do -script, and then you can really initiate the script if you have any bash in the same directory. But if you do just -bash : then you can just put pwd and it's going to trigger.
Oh, cool. That's awesome. So it was, what we're talking about here is by adding those extra lines. So since I added script, pwd is telling me the working directory right there. You can put whatever you want. So you're saying you can add it, change it to bash? Cool. Yeah, so there's lots of commands that you can enter in there, and in the reference page at the end of the PowerPoint, there are a list of all of the tasks that you can create in a YAML file. So unfortunately, it takes about 15 minutes to do a deployment of the app and get the release pipeline set up. So we won't be able to cover it this time, but that's right up number one when we get to the next session in 2 weeks. Does anyone have any questions about this process or anything in general, or did I say something incorrectly? Please let me know.
Mike, just also maybe just give some a little bit more for appetite for the next sessions. Can you back to your YAML pipeline here on the right specifically?
Sure. Cool. Let me make this bigger now that we're not using the left side.
Actually, I wanted to compare with the left, but
oh, okay. Sorry, there's a police car. All right.
Did you do something wrong?
No, it's just I live in a noisy area. I'm safe, I swear. All right, gotcha. So yeah, there you go.
So what I wanted to mention here, guys, right? It's you see the line number 9. What it really means, what Mike mentioned before, it was that right now what we're doing, we're utilizing the containers, and this is what we get for free with Azure Pipeline, right? So right now you're in one container. Let's say if you would set up multi-stage job, right, and gonna have a different triggers, and one of those examples would be Terraform, which requires init to initialize, plan to see if there's any errors, and apply to deploy the resources. So it would be 3 shell scripts, right? So each of those jobs would go to the different pool. So what we would require to do is just making sure we pass the variables from one job, from one pool to another. It's a little bit more complex. I mean, I'll explain over, just without demonstrating it, but maybe we can include it in our future series.
Yeah, that's a great idea. We want to make a complex multi-stage build and release YAML pipeline next session. So we'll try and include something about other build agents.
Cool. Thanks, Mike.
No problem. Anyone else have any other questions? All right, so yeah, next session, October 31st, we're going to be talking about continuous deployment. See, on the second slide I wrote delivery, and this time I wrote deployment. We'll be converting our build artifacts to Azure artifacts, and we'll be creating a multi-stage YAML pipeline. Homework, if you're down for this, create an ARM template for an app service plan and a site, and create a YAML build pipeline with the tasks that will create the ARM templates artifact and the .NET Core web app artifact. And if you have extra time, like we didn't today, see if you can figure out how to release it to Azure. If not, we'll be covering it in the next session. And
yeah,
here's
Mike,
all the links. Yep.
Yeah, sorry. I'm David here. Apologies for that. So I do have a question. So when it comes to the use of variables in the pipeline that you just showed us, so if I want to use like a global variable that carries on like throughout all the tasks, is there kind of like a straightforward way to do that? So a good illustration would be trying to do something where I need to make an API call and I need to put an API key, but then it's something that I may need to reference throughout the entire throughout different tasks in the pipeline.
Sorry, I'm not quite sure. This is a list of all the predefined variables, but are you talking about creating a custom variable?
Yes, so sort of like so let's say I'm going to be running different tasks, and with the different tasks I'm going to be making certain API, right? On sort of like a variable that will include something like an API key.
Right.
That
Mike, do you mind if I?
Oh, I see what you're saying. Yeah. Go ahead. Thanks, Len.
Hey, thanks, David. Was a long time no talk. Glad to hear your voice here on our session. So the good example would be, again, coming back to our good friend Terraform, right? Let's say you have a tenant password, right? And you're going to store it in the key vault. Now you need to pass it to your initialization job, right? So that's exactly where you're going to put this value first. You're going to pick up this value from the key vault. You're going to drop it to the pipeline YAML file, right? This is exactly what Mike just demonstrated it. But then you still need to carry this value over to your initialization job, then plan job, and thereafter the final apply job. So you could definitely do so. And I think that for the next session, Mike, maybe we could really put more examples on how to do this. And we actually have it running, and like Mike and I, we updated it before in one of our pipeline job.
Yeah, I think then the next session, or when we start to improve on the application, I still don't know what our app will do right now. It's still Hello World. We'll incorporate a database that has that needs some variables within the pipeline, and we'll use the key vault to store secrets, and we'll actually make some custom variables in the YAML pipeline as well.
And did it to answer your question, or?
That was very good. Thanks very much.
Cool.
Yes, no, for sure, definitely. Yeah,
okay, yeah, then feel free to reach out to us. I mean, again, you're a lone good friend of ours, so we'll be more than happy to show you exactly how it is done in the YAML file.
Yeah, no problem. No, thanks very much for that.
Cool. Any other questions? Awesome. All right, everyone, then we'll see you for the homework maybe next week, same time, and then followed the following week will be the continuous deployment session. Thanks, everyone.
Mike.
Yep.
Thanks, everyone.